First, let's start with the definition of continuity. A function is said to be continuous at a point if the limit of the function as x approaches that point exists and is equal to the value of the function at that point. In other words, if we can draw a line in that point without lifting our pen, the function is said to be continuous at that point. To better understand the concept, let's take a look at this visualization. We have here this graph. Now, we need to determine if the given function is continuous at x is equal to 3. How? Like what I said earlier, we can determine if it is continuous at a certain point if we can draw it without lifting our pen. So as you can see, we can draw it from here through here effortlessly without lifting our pen. Hence, the function is continuous at x is equal to 3. Now, look at this graph. If we want to know if this function is continuous at x is equal to 3, we should be able to draw these lines without lifting our pen through this point x is equal to 3. Now, if we try to do it, we won't be able to go past through it because the line stopped over here. That means that the function is discontinuous at x is equal to 3. Now, what if there's no graph? There's only a function. We can still be able to determine if it is continuous or not. Consider the function f of x is equal to x squared. We want to determine whether this function is continuous at the point x is equal to 2. To do this, we need to evaluate the limit f of x as x approaches c is equal to f of c. We can do this by plugging in the value of x, which is 2. If a value exists, that means that the function is continuous at x is equal to 2. If we try to substitute x for 2, we can have 2 squared, which is equal to 4. That means we have a value for the f of c. Hence, the function is continuous at point x is equal to 2. Let's now practice on this example to better exercise your understanding regarding our topic.
Using this graph, determine if the function is continuous at point x is equal to negative 2. And the answer is, it is continuous, since we can draw the function through the point x is equal to negative And the answer is, it is continuous, since we can draw the function to the point x is equal to negative 2 without lifting our pen. It confirms that the function is continuous at x is equal to negative 2. Determine whether the function f of x is equal to 1 over x is continuous at x is equal to 0. And the answer is no. The function f of x is equal to 1 over x is not continuous to x is equal to 0. Since the limit of f of x as x approaches 0 does not exist.
In conclusion, the continuity of a function at a point is determined by evaluating the limit of a function as x approaches that point and comparing it to the value of the function at that point. If the limit of the value of the function are equal, then the function is continuous at that point.